To illustrate the basic ideas in their plainest form, let's start by writing some expressions in Origami using the command line interface called Ori. If I type Ori 1 plus 1, it evaluates that and displays 2. If I type Ori hello, Ori displays hello. In the shell, you'll need to escape quotes or surround them with extra quotes because the shell itself consumes quote marks.
In addition to basic numbers and strings, you can reference files. Think of each file as if it were a spreadsheet cell. Instead of the A1, B2 style cell references in a spreadsheet, we can use paths and file names to refer to things. Unlike most programming languages, names in Origami can include characters like periods and hyphens.
Where a spreadsheet has built-in math functions, Origami has built-in functions for transforming data and creating parts of sites. We can call a function that transforms Markdown to HTML, giving it a Markdown file as input. To avoid having to quote parentheses in the shell, we can omit them, and Origami will figure out where they would be.
In addition to the file system, Origami can work with other hierarchical tree structures like objects in memory, data in files, or content on a server. Just like your operating system can associate file extensions with particular applications, Origami can associate file extensions with functions that know how to unpack that kind of data, so you can traverse into the data with a path like this.
Origami resolves references using the same kind of scoping that programming languages provide, but Origami's notion of scope extends to the file system. If I try to display the README file and that file doesn't exist in this folder, Origami searches up the folder hierarchy and finds the README in the project's top-level folder.
You don't have to know JavaScript to use Origami, but if you do know JavaScript, you can use it to easily extend what Origami can do. You can write a function like this and then call it from the shell. Using a file association for JS files, Origami imports the JavaScript module and calls the function it exports. You can freely compose these ideas, so you can read data out of a file and then pass it to a JavaScript function.
As an Origami expression grows in complexity, you can save it in its own file so you can invoke it by name. If we ask Origami for this .ori file, we get the file's contents back. Adding a slash lets Origami know we want to evaluate the file as an expression. So this kind of .ori file is like a spreadsheet cell that contains a formula. Instead of looking at the formula, we can ask to see its value.
Origami is good for creating lots of things, but especially websites. You can think about a site as a tree of resources. To define that tree, you can create an expression that defines an object. This tiny object has a single property called A, and like with any other tree, we can use a path to traverse that tree and get the value of that property.
You can define a website with an Origami file that creates an object with the structure you want. This little site has a single page called index.html. We'll define the value of that index page by calling a function to say hello.
And we can serve the tree defined by this file and then navigate to that location in a browser to see the index page. Although this particular site is trivial, creating a real site is just a matter of filling out the site's tree with more pages and content.